Hey everyone, what's up? In the last video, we implemented this compute legal moves method for our night class, and we are going to do this for our king class. So what we did for the night was firstly to create an empty list of squares. So let me copy that and reuse it. Oops. Wait a second. All right. And we are going to return that in the end. So let's go back to our night once more. As you see, what we did was check each possible square that a knight can go potentially and add the square if it's eligible. So we were checking the squares according to the moving pattern of the knight piece. So the moving pattern of the king is a bit simpler. So it can go one of its neighbors, basically. It has 8 neighbors at maximum. So we are going to simply iterate over a nested for loop, which will check each neighbor, and we're going to see if it's eligible or not. So let me type the nested for loop first and explain to you later. Alright, what I'm doing here is the outer for loop iterates over the horizontal neighbors, and the inner one iterates over the vertical neighbors. So it starts with -1 and stops at 1, which means, for example, for the first loop, start from left and center and right. Similarly, this inner loop checks first bottom and center, finally top. So this nested loop in total checks 9 squares. So our piece has 8 neighbors, but this loop is checking 9. So it's also checking our initial square as well. That's because at one point both h and v will be both 0, so that corresponds to our initial square. But it's not a problem because it's occupied, and our let me show you, this check square method will ignore that, so it's not going to add that square to our legal moves. Actually, let me go ahead and move this method from the knight class to my piece class, because this excuse me, this method will be reused in all our pieces. So also let's make that protected. Alright, so the only thing we need to do here is create our target square reference according to our initial square. So get adjacent square h and v. So quickly I'll show you here. The get adjacent square method accepts the horizontal offset first and the vertical offset second. So that's why we are giving h first and v second. And now we are going to call this check square method, basically. it accepts our legal moves list and the target square. That's it. It was very simple. Firstly, because we already have this check square method, we don't have to type all those once again. So, but still, I'm going to tell you quickly what we did in the previous video. We are going to check if the target square exists in the first place. If it exists, it can be empty or it can be occupied by a piece with the opposite side. If this condition is true, we can add that square to our legal move lists. That's all. The king class is complete, and we're going to continue with our other piece types in the next videos. And let me tell you a final thing before I conclude this video. This compute legal moves method for our king class covers only the regular moves of a king piece. So it does not cover the castling move, obviously, but we are not going to implement it today. We will come back to that issue later. So here it is. See you in the next video. Take care.